Each of the multiplication rules for powers that we looked at last class has a corresponding division rule. All right, so if you remember, products of powers, you would have same base, different exponents being multiplied together. You keep the base, you add the exponents. Okay, quotient of powers will be same base, different exponents, dividing the two terms. And the shortcut rule will be keep the base, subtract the exponents. All right, keep the base, subtract the exponents. So 3 to the 8th divided by 3 to the 6th would be 3. 8 minus 6 is 2. 3 to the second power. Okay, 9 to the 7th divided by 9 to the 4th would be 9. 7 minus 4 is 3. 9 to the third power. A to the 5th divided by A. Remember, A, just plain old A is the same as A to the first power. So A to the 5th divided by A to the 1st would be A to the 4th. 5 minus 1 is 4. Okay, that's how quotient of powers shortcut works. Why does it work? Very similarly to why products of power works. If I write out, for example, 3 to the 8th divided by 3 to the 6th, and I expand the numerator, that will be 3 times 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 3, right? 8 threes multiplied. And I will also expand to the denominator, 3 times 3 times 3 times 3 times 3 times 3. Okay, six threes as factors. Right? And if you remember back from your elementary school days, if all you're doing is multiplying things in the numerator and denominator, you can cancel terms, right? 3 divided by 3 is just 1, so I can cross them out. So we would cross out all 6 of our denominator 3's, and in the process we would cross out 6 numerator 3's, and we would be left with just 2 3's in the numerator. Okay, so that is why keeping the base, subtracting the exponents works. Powers of quotients, similarly to powers of products. Remember, with powers of products, you would have two things multiplied together inside of parentheses, and then that would get applied, that would get an exponent applied to it. Okay, this is similar. We have two things together inside of parentheses that are being divided, and then an exponent is being applied to that quotient. Okay, the shortcut in this situation is the exponent distributes to each of the factors. Okay, same shortcut as powers of powers. So this would mean 8 to the 5th power and also 4 to the 5th power get divided. Okay, and remember, this is the situation where it may look just as complex. The simplified form may look just as complex, but what we're doing is getting rid of parentheses. N squared over 11 squared. All right, and this last one, remember, negative value inside of parentheses. The final result will be negative if the exponent is odd, positive if the exponent is even. So in this case, negative 5 taken to the third power will still be negative 5 to the third over x to the third. All right, that's how it works. Why does it work? I never wrote this out, did I? Distribute the exponent to each factor within parentheses. All right, why does it work? We'll go with the one in the center. Or let's go with the bottom one, since it's got that negative situation that we can remind ourselves of. Okay, so definition of exponent: what's inside of this parentheses gets multiplied by itself 3 times. Okay. And if you remember from your fraction rules, again, elementary school, if you're multiplying fractions, that's the easiest thing you can do with fractions, because you just multiply the numerators, keep them in the numerators, multiply the denominators, keep them in the denominator, and you would end up with this situation. Okay. Before I switch the Before I move to a different rule, let's look at what happened right here, because this actually can be simplified farther using powers of quotients backwards. Okay, backwards version of powers of quotients. If you remember, there was a backwards version of powers of products. This is the situation. If we have same exponent, different bases, and we're dividing, we can keep the exponent and divide the bases. All right, so I'm gonna write 2 more like this up here. Let's say 100 to the 3rd over 5 to the 3rd, and 4 to the 15th over 20 to the 15th. All right, so keep the exponent, divide the bases, shortcut, 8 to the 5th over 4 to the 5th equals 2. 8 divided by 4 is 2. Keep your exponent. Okay. 100 to the 3rd divided by 5 to the 3rd. Keep our exponent. 100 divided by 5 is 20. And lastly, 4 to the 15th over 4 to the 20th. Keep the exponent. Okay. Now we are going to run into an issue here. 4 divided by 20 is less than 1. All right, we're still going to have a fraction. 4 divided by 20 is 1/5. All right, so the exponent is actually going to stay with the denominator in that case. All right, 1 over 5 to the 15th. Okay, why does this work? Again, this is similar to powers of products backwards. This is one of the harder ones maybe to reason through. If I expand the quotients, if I expand the powers of quotients, or if I expand the numerator, 100 times 100 times 100, and I expand the denominator, 5 times 5 times 5, and then I apply laws of fractions, I can divide each of these separately. So 100 divided by 5 is 20. 100 divided by 5 is 20. 100 divided by 5 is 20. And that's where we get our 20 to the 3rd power. Sometimes when we're applying the quotients of powers rule, we'll end up with exponents of 0, or we'll end up with negative exponents. All right, that's going to happen in each of these cases here. Remember, power of, or quotients of powers means you're starting with your same base, different exponents. All right, in this case, it's the same exponent as well, but same base, and we're dividing. Okay, and our rule is keep the base, subtract the exponents. All right, so this would be 5 to the 0 power. This guy here, 8 minus 14 is negative 6. And this guy here, remember, m by itself means the same as m to the first. So m, 1 minus 4 is negative 3. Okay? Now, two different rules, right? 5 to the 0. You are going to be tempted to say that the answer to this is 0, and you're going to be wrong if you do that. This is one of the number one mistakes that I have students make with this topic, right? 5 to the 0 is not 0. Let's think about what it is. I'm dividing a number by itself, okay? Resulting in an exponent of 0 means I've divided something by itself. And what do we get when we divide a number by itself? We get 1. Okay, so by definition, any number to the power 0 equals 1. Simplifies to 1. Any number to the power 0 simplifies to 1. Okay, second biggest mistake that I have people make is misreading this rule and simplifying only the power to 1 and saying that this equals 5. It does not. Okay, when I say any number to the power 0 simplifies to 1, I mean the final answer is the number 1. All right, a number divided by itself is 1. Okay, so it doesn't matter. You could say 5,000 to the 0 power. The answer is 1. You could say g to the 0 power. The answer is 1. Right? Any value to the 0 power, the answer is 1. All right. Now, negative exponents are not allowed in the simplest form of powers. Right? So one thing you always have to do is get rid of parentheses. Another thing that you always have to do is get rid of any negative exponents that you have when you're being asked to simplify powers. So what is a negative exponent? Well, shortcut, negative exponents flip powers over fraction bars. Okay? Negative exponents flip powers over fraction bars. What do I mean by this? 2 to the negative 6th is the same as 1 over 2 to the 6th. M to the negative 3rd is the same as 1 over m to the 3rd. Okay? This negative exponent pulls what was a normal numerator number down into the denominator. Right? And when you do that flip, when you flip over a fraction bar, you simultaneously can get rid of your negative. All right. First, let me show you how that works and then talk about flipping the reverse direction. So why does it work? Same reason that our quotient of powers rules works. Right? If I expand out this, m divided by m times m times m times m, okay, I'm going to be able to cancel. M divided by m is 1. I'm left with 3 m's in the denominator. I'm left with 1 in the numerator. All right, no m's, but remember, no factors means 1 is the answer. So 1 over m to the 3rd. Okay, that's how you build that shortcut rule. Let's look a little bit more at some negatives before I move on. Two situations, all right? So 5 to the negative 3, 1 over 8 to the negative 2, 1 over 4 to the negative 9. Okay, so as I said before, negative exponents flip powers over fraction bars. Right? If a fraction bar is in the numerator, or if a power is in the numerator, or you don't see the fraction bar at all, very simply, you move that power to the denominator. All right, 1 over 5 to the third. If a negative power is in the denominator, it flips upward. So this would become 8 squared over 1, or just 8 squared. Okay, so if the negative power, negative exponent is already in the denominator, it still flips that power over a fraction bar, and it flips it up into the numerator position. All right, 1 over 4 to the negative 9 would be 4 to the 9. 4 to the 9 over 1 is 4 to the 9. Okay. Again, why does that work? You're going to have to remember how division of fractions works. If we look at 1 divided by 8 to the negative 2, which is 1 over 8 to the 2, all right, I'm dividing 1 by this fraction. Okay, and remember, if you're going to divide by a fraction, it's the same as multiplying by its reciprocal. So 1 divided by 1 over 8 squared is the same as 1 times 8 squared over 1, right? Division by a fraction is the same as multiplying by its reciprocal, okay? So that's the why behind negative exponents flipping powers over or under fraction bars, depending where they start. There's a ton of power rules. Probably it will be difficult to memorize them all. You can use expanded notation to rebuild your power rules from scratch if you forget them. There's another thing that could help you, checking for correctness. Okay, let's say you're in the middle of a quiz and you've got to answer, you have to simplify 4 to the 9th times 4 to the 5th. Okay, and you can't remember what is the shortcut rule, and you don't feel like writing a bunch of 4s out and counting them. You can do this. All right, let's say that you think same base, different exponents, I'm multiplying. Probably I should keep the base and multiply my exponents, right? 4 to the 45th power. Now this is wrong, right? It's a wrong answer, but it's a common mistake that students make. You should be able to catch this wrong answer before you turn in your paper, right? How does this work? Let me get a calculator. You type the original into a calculator, right? 4 to the 9th power. Ooh, let me tell you this too. Can't believe I have not said it yet. Most upper level calculators that you'll use. So this is a Casio graphing calculator, TI graphing calculator, the scientific calculators that I have in my classrooms. Most of them, when you want to put exponents above square, you want to put exponents, you use a button that's got a little up arrow, right, to input your exponents. So I would be pressing 4 up arrow 9 to represent 4 to the 9th power. Okay, so I'm going to do 4 to the 9th power, 4 house 9 times 4 to the 5th power, 4 root 5, right? And here is my answer, right? My numerical value for this expression, 268435456, right? That is what this equals, okay? We're like at 268,435,456. Now, I'm going to check this numerical value against the numerical value of 4 to the 45th power. All right, 4 to the 45th power gives me 1.2379 and some more numbers, E27. All right, now, for the checking purposes, the only thing that we care about is these don't match, right? If they don't match, then this is not a simplified form of that, right? Just for your reference, what does this E27 mean? This is scientific notation of sorts. It's meaning this long string of numbers, we're going to multiply that times 10 to the 27th power. So we shift the decimal point 27 spaces to the right. All right, so we actually have a really huge number. This number is too big to fit in the calculator. That's why they use this notation. All right. Anyway, for our purposes, all we care about is 4 to the 45th power doesn't match, does not match 4 to the 9th times 4 to the 5th. So I know that I was wrong when I guessed I was supposed to multiply the 9 times the 5. So I could try something else. Maybe I'm supposed to do this or that. All right, we happen to know, hopefully, or we could look back at our rules. What I'm supposed to do is keep the base and add the exponents. 9 plus 5 is 14, right? And if I put 4 to the 14th power into the calculator, I'm going to get the same answer as when I put 4 to the 9th times 4 to the 5th. All right, same answer. They do match. I'm confident. I know I'm right. And I move on to the next question. Okay, so even though there's a lot of different rules to learn, you can always check if you've done the problem correctly before you turn it into me. Okay, so you should get 100 on this test, on this quiz when I give it.